Okay, now we talk about the molecule present in crude oil. And actually, in the crude oil, it is a mixture of many different types of hydrocarbon. Okay, that means some small hydrocarbon, some medium-sized hydrocarbon, and some very large-sized hydrocarbon mixed together, and then that is crude oil. And molecules of different hydrocarbons are made up of different number of carbon and hydrogen atom. Okay, this is an example. Just one carbon atom and then 4 hydrogen atom combined together. That is methane. And now you can see it may be 1 carbon, 2 carbon, 3 carbon, or 4 carbon atom joined together. And of course, with hydrogen atoms. And then we will have very small, medium, and a little bit large size. We have different size molecule. So crude oil is a mixture of hydrocarbons. Okay, so write down the answer in your book. And different hydrocarbon molecules are of different size because they are made up of different numbers of carbon and hydrogen atoms. Of course, only 1 carbon atom, the size is very small. If we have 4 or more carbon in the molecule, the size, of course, larger. Okay, refining crude oil. Okay, we cannot burn the crude oil directly. We cannot use the crude oil directly because some very large molecule of hydrocarbon is mixed inside the crude oil. If you just burn it, you will produce a lot of black smoke and harmful gases. Okay, if we just take a look of the crude oil, it is a mixture. You can see very small molecule, medium size, and very large size molecule mixed together. All of them are hydrocarbons. So to use the crude oil effectively, we need to separate different hydrocarbon. That means we want to take the small size, we want to separate the medium size, we want to separate the large size. Okay, we separate. So, and this is refining. So the principle is that if the molecule is very small, the boiling point is very low. If the molecule is larger, the boiling point is higher. Okay, so if the size increase, the boiling point also increase. So we go to right hand side, the size is larger and the boiling point is higher. So we know that the hydrocarbons will have different boiling point. Okay, different size will have different boiling point, and then we can separate. And what is the method? The method is called fractional distillation. Okay, and then the product we get, we obtain, that is fractions. Okay, we have a video about an experiment. We take a look of the video.
Crude oil is a mixture of compounds called hydrocarbons. The hydrocarbons can be separated into different fractions based on the difference in boiling points of the hydrocarbons by fractional distillation. First, heat the crude oil gently with a small Bunsen flame. Collect any distillate coming out in the test tube before the temperature reaches 80 degrees Celsius. The distillate collected is the first fraction. Remember to stop at the test tube because the distillate is volatile. Replace the test tube with a new one. Heat the crude oil more strongly to obtain a higher temperature. By adjusting the temperatures, we can obtain a number of fractions. Now we have obtained 5 fractions of crude oil.
Okay, we take a look of the experiment. This is fractional distillation of crude oil. Okay, we will increase the temperature here step by step, and we will start with the lower temperature. Okay, and then we want to separate different size molecule. At first, we heat here gently, and then the temperature is lower. The small size molecule will vaporize, become gas, and then they will come out. And the gas here, this is ice water. The air cool down, it will become liquid, and then we will collect the first fraction. Okay? So we heat here uniformly. The first temperature is lower, and that is around 80 degrees Celsius. And then the small molecule will vaporize and then come out and cool down and then become liquid. So we collect here is first fraction, and that is smaller molecule. Okay, so we label first fraction number 1. Remember, use a stopper to prevent the liquid vaporize and leave the test tube. And then we increase the temperature a little bit more. Now it is 80 to 150 degrees Celsius. Because the temperature is a little bit higher, a little bit larger size molecule will vaporize and then come out and cool down, and then we will collect the liquid. And that is number 2, and this is a little bit large size molecule. And then we'll repeat the same situation with higher temperature and then higher temperature. So we will have higher temperature, we will call that number 3, more temperature, more higher temperature, and then we will call that number 4. So we will have 4th fraction. Okay, and then we studying the properties of different crude oil fraction. We have 4 fractions. Okay, we take a look of the video.
These are the fractions obtained from fractional distillation of crude oil. How do the properties of these fractions differ from each other? Observe the colors of different fractions. Can you notice the trend? Tilt the stoppered test tubes one by one to see if the liquid fractions flow easily. The more difficult the fraction flows, the more viscous it is. Which fraction has the highest viscosity? Put a drop of each fraction on a piece of filter paper to find out the order of the ease of evaporation. Which fraction evaporates most quickly? Light each fraction in an evaporating dish to see if it burns easily or not. And note the amount of black smoke produced when it burns. What conclusion can you draw from the above observations?
Okay, now we take a look of the experiment. Different crude oil fractions, they have different properties. Now we take a look. Observe the color. Just take a look. Each fraction, take a look of the color. And chew the test tube one by one. Take a look. Does it flow easily? And then put a drop of each fraction on a piece of filter paper and then take a look which of them evaporate most easily. And take the fraction on an evaporating dish and then burn it. Okay, take a look which one have black smoke during burning. Okay, this is the result. In your book, you write down the answer. Okay, fraction number 1, small molecule. Fraction number 4, this is the largest molecule. And take a look of the color. If the molecule is larger, the color is darker. Okay, so number 1 is colorless. Number 2, very pale yellow. Number 3, yellow. Number 4, brown in color. And then viscosity. Small molecule is very easy to flow, so the viscosity is lower. And high viscosity, that means it is not easy to flow. And then easy of evaporation. If the molecule is very small, it is easy to become vapor. And if the molecule is very large, it is difficult to become vapor, so it will stay liquid. And easy of burning. Small molecule is easy to burn and large molecule is difficult to burn. And for the black smoke, small molecule, small amount of black smoke, and for large molecule, a lot of black smoke produced when burning. So this is the discussion. The higher the boiling point range, that means the molecule size is larger and the color is darker and the viscosity is higher. Okay, higher boiling point, the molecule size is larger. Okay, higher the boiling point, larger the molecule size, it is more difficult to evaporate and more difficult to burn. For higher the boiling point, the molecule size is larger and more black smoke will produce when burning. Okay, this is the key. Write down the answer on your book. The hydrocarbon in crude oil can be separated into different fractions based on the differences in boiling points of the hydrocarbons by what is the method? Fractional distillation. Okay, I pause here.